Hello and welcome to this episode from Range Woodworking. If you've watched my video making a custom honeycomb display frame, you might recognise these struggles I had. The stainless sheet was just too hard for the pneumatic nibbler, causing it to jam relentlessly. Plus, my compressor had to refill every minute or so. When I got a drill-driven nibbler, I didn't have that problem, but I did have to put up with tiny, super sharp sickle-shaped steel pieces that stick in everything, including my nose back when I had a mustache. That was unpleasant. Let's see if we can do better. I'm using some 17mm form ply I had kicking around that I'd actually previously used as a concrete form, so I'll give it a quick clean up first. Next, I'll lay out my cuts on the board and cut it all down on the table saw. I use cutlistoptimizer.com to organise my layouts for maximum efficiency. It's an awesome free tool that makes life a lot easier. I'll have a link in the description. After a few rip cuts with the fence and cross cuts with the miter gauge, we have all 7 pieces needed for this build. Once sliced and diced, I start putting this jig together, starting with the underside brace pieces. I attach the brace to the larger of the two first, because these pieces will be separated by the width of the saw kerf. To be honest, this many screws is probably overkill, but at least I know they're not going to go anywhere. And with a dramatic entry, this is the metal cutting blade I'll be using to cut the sheet. As you can see here, it's for stainless steel under 2mm, has a max speed of 5800 RPM, which is the same as my saw, but most importantly features a 1.4mm kerf. Enter the 1.5mm window packer. I place the packer between the two face pieces and clamp them in place whilst throwing another bunch of screws in. Apparently the gap is a bit snug because they certainly take some wrestling out. Come on, put your back into it, Dan. Alright, that's our foundation done. You'll notice it slips and slides all over the place, but more importantly, I'll just check that it accommodates the saw kerf with a lazy roll along. To stop the form ply slipping and sliding all over the place, I'll utilise these little silicone cutting board feet. I quickly just screw them into the braces, and before you know it, I have a good, sturdy, non-slip base. This is the DeWalt 54V circular saw I'll be using. Whilst I install the new blade, I should add I probably wouldn't use your best circular saw for this, as any metal shavings getting into the motor could kill the saw. But I only have this one, so it will have to do. Now I want to install my material support rests with enough clearance for the base plate of the saw. I figured the easiest way to do that was to just put the saw on the jig with the blade in the groove it'll run in, and then measure both sides. I pop the packers back in the groove to use as references, and to make sure my material supports are square to the travel path, I use this big old framing square. Some superglue and activator holds the support piece in place whilst I throw some screws in again. For the support on the other side, I just use the straight edge of the framing square to ensure the two sides line up. Some more superglue goes down, and then the weather distracted me apparently. It was sunny this morning and now it's raining so hard the gutters are overflowing. And it's about now that I realise I'd put some superglue down and needed to install that second fence. All good though, I get it clamped and screwed in place. The fence will be raised using these 3mm packers. One of the benefits of these is they can be trimmed quite easily to suit using these nips. Superglue will hold the packer in place until the fence is properly installed, and to make sure the edge is in line with the support rest, I just use a steel rule. Now, the honeycomb frame that I use the stainless steel for has two default widths of steel, so I'm going to set a pair of material stops that will give me quick and repeatable widths. The first width of which is 50mm, so I measure 50mm out from the cut and clamp this steel offcut in place. Or at least I try to. Apparently operating these clamps one-handed is harder than it looks. I felt the easiest and most accurate way to set these stops is with a simple through bolt. So once clamped in place, I drill through the steel with a bit that's far too big before applying my big old brain and just using a smaller bit. When this just punches through the steel, I remove it and finish drilling a hole in the base. I then tap this hole and screw in my favourite coil inserts before punching the tail off. I love these inserts, they're cheap, strong, quick to install, and most importantly, completely foolproof. And once I've finished, an M5 screw will hold the stop in place with zero play or deflection. Obviously, if you are making this jig, you could make a sliding adjustable depth stop, but I just need the 50 and 45mm for now. Then the hero of this build, the framing square, makes a return to set the second stop using the same method. I quickly installed the packer for the far end of the fence before making a quick improvement to the fence itself. These adhesive little foam discs usually go inside cupboard doors to silence them when they're closing. I'm going to stick a bunch of them to the underside of the fence, which will help prevent any steel sliding all over the place on the form ply. I then use some 10mm packers to raise the framing square up so it can set the fence square to the material supports. I raise the square up so that it's against the fence rather than the packers underneath, which are just there to elevate the fence. As you saw, they weren't installed with much care or accuracy, so it's really important to go against the fence and not the packers. The usual superglue, clamp, drill and screw, and I'm pretty sure that's rapidly becoming the theme of this video. To further improve the safety and security of this jig, I'm going to add a quick clamp to hold the material down under the fence. I'm not sure that makes much sense, but it will, I promise. I drill through the jig to accommodate this T-bolt, and then I mark the base to make a recess for the bolt to sit in. A Forstner bit removes the majority, and then I just tidy it up with a Stanley knife. A bit of encouragement, and we're good to go. I think it's time for a test drive, or it would be if I could screw this on. Okay, so material in, firm against the fence and clamped. Glasses on and saw set to depth. And just like that, we've cut a straight, clean, parallel piece of steel with minimal burr. I give everything a good air dust off, especially the saw and motor, before checking how we went. And I am happy with that. All that's left to do is put a French cleat on the back and store the jig on the wall. I hope you've liked this video, and if you have, please consider liking and subscribing. And if there's anything else you think should be on there, let me know in the comments below. Until next time, take it easy.